Okay, in this video, we are going to start section P-5, and that is factoring polynomials. Here's a little list of the bullet points that we'll get to. Factor out greatest common factor, factor by groups, factor trinomials, difference of squares, perfect squared trinomials, sum and difference of cubes. I think we'll get through those concepts in this first video, and then in the next video we'll do the general strategy for factoring polynomials and with positive and negative exponents. I missed in there, oh, the sum and difference of cubes. That will be actually in tomorrow. Yeah, we'll get up 1 through 5 today in this video, and then 6 through 8 in the next video. All right, for factoring, the simplest thing to do is factor out just a common term. Like here's a 10x squared plus 15x. If you look at the numbers, the most common factor from 10 and 15 is 5, so we can bring a 5 out. And then we have an x squared and an x to the first. We can factor out the lowest power. So when we pull out a 5x, the remaining in the parenthesis now is a 2x plus 3. And let's check example 1. They're going to follow this pattern here. So in letter A, I'm looking at the numbers. I see an 18 and a 27. 18 and 27 both have the common factor of 9. And then we got an x cubed and an x squared. We can factor out the least of those. That would be x squared. And then we got to figure out, I'm going to fix that too. Almost as better. Now we want to figure out what's left here. So 9x squared, if we distributed and we multiplied it by what's here, we should get back to 18x cubed. So 18 divided by 9 is 2. And then x cubed divided by x squared would be x to the first plus. In the second term, 27, we factored out the 9, so divided out. That leaves you with the 3. And this x squared got factored out entirely, so it's gone. So we can close our grouping symbols. If you're not sure if you're correct, we can distribute to see if we get back to the starting problem. So 9 times 2 is 18. X squared times x is x cubed. And then we distribute here to the 3. 9 times 3 is 27. And the x squared comes along for the ride. All right, in letter B, it's kind of bigger. Notice we have a group here of x plus 3 and a group of x plus 3. First, let's notice where the addition or subtraction sign is. It's right here in between these two terms. And if I put some brackets around here, I could say, okay, what can we factor out of each term on either side of the plus sign? Well, each factor, or each term has an x plus 3 factor. So we're going to pull that outside of the brackets. So bringing out here, we have an x plus 3. Now let's see what's left inside. We've factored this out entirely, so we're left with an x squared. And we factored this x plus 3 term out in front, so we're left with a plus 5. X squared plus 5 is the remainder that make up the second binomial. All right, in example 2, they tell us it's going to be a factor by grouping. Usually they have 4 terms. Leading term is usually a cube. So if we group off the first 2 terms, we can pull out an x squared, leaving x plus 4. The second group we can also bracket off, and we can factor out a 3 plus 3. And we factor that into x plus 4. Now it's like a lot like this problem right here, B in example 1. So what we can do is imagine some brackets around the whole thing. And on each side of the plus sign, we have an x plus 4 term. And then after we factored out the remainders, the leftovers are an x squared plus 3. And there's our final answer. We should always check, can we factor this any farther? No, that's in its lowest factored form. And same thing with this linear factor x plus 4. We can't factor it any further. So here's a practice problem for you to try real quick. It's just one. So if you pause the video, try the problem, and then fire it back up, see if you got it right. Be careful with these minus signs. All right, if we factor this by groups, first group, pull out an x squared, leaving an x plus 5. Now here, in this group, it's a negative 2x and a negative 10. We're going to factor out the negative with the 2. Now what that's going to do is switch our signs here. This negative 2x is now a positive x, and this minus sign here with the 10 also got switched when we factored the negative out. So that's going to switch to a plus 5. And that's important because these terms have to be the same, you know, x plus 5 and x plus 5, so we can factor it outside of these brackets. So now the x plus 5 is its own term, and the remaining pieces are the x squared and the minus 2. So there's our correct answer. All right, now just a general strategy here for trinomials. It says here a strategy to factor a x squared plus bx plus c. Well, we know that the first two terms must multiply to that leading term, some number ax squared. So you're going to have something x, you multiply them and you get something x squared. The last two terms, the numbers at the end, should multiply to be that constant at the end, the c value. And then we got to make sure, and it says here by trial and error, perform steps 1 and 2 until the outer and the inner product is the number you're looking for, that b times x. And there's some strategy to this. It's not just trial and error. I'll show you a couple tricks. Like here, example 3, leading coefficient is 1. They want us to factor it. So I would tell my students, here's the number here, 8, positive 8. And we want to figure out what numbers multiply to give you an 8. Well, that would be 1 times 8 would work. 2 times 4 would also work. And then 3 doesn't divide evenly. If we get to 4, it's just going to be a reverse of this, 2 times 4. And then 5, 6, and 7 won't work. 8 and 1 we already have here. So now if we look across these rows, we have two numbers that multiply to this number, 8. We want to find in those rows two numbers that add up to positive 6. And that's an easy one. If we add these numbers, we get 9, so it's not the 1, 8 breakdown. It's got to be the 2 and the 4. 2 and 4 add up to 6, and they multiply to 8. And this is a nice, easy problem. Everything is positive, so this will be an x plus 2 linear factor and an x plus 4 linear factor. In example 4, leading coefficient is still 1, but now we got a plus here and a minus at the end. So the strategy is still going to be kind of the same. I'd ask myself, okay, what numbers multiply to 18? 1 times 18 will work. 2 times 9, that's supposed to be a 9. 3 times 6, 4 doesn't work, 5 doesn't work. When we get to 6, we're back here, we just reverse all of these. So now we want two of these, or one of these column or rows, to add up to positive 3. But remember, since this is negative 18, one or the other of these will be negative. So 1 and 18 aren't going to work, 2 and 9 won't work, 3 and 6 will work, and to get a positive 3 in the middle, we're going to want to make that a positive 6, get over there, positive 6 and a negative 3, because 6 and negative 3 add up to 3, and they also multiply to the negative 18. So our two linear factors, x minus 3 and x plus 6. And if you're not sure of your work, you can always FOIL it out to see if it checks out. Again, our first times first will give us the x squared. The negative 3 and positive 6 will take us to the 18. And then it's the outers and the inners. Here the outers would give us a positive 6x. The inners a negative 3x. Okay. Here are some practice problems. You got 6 of them. So I would say pause the video, solve the problems, and then turn the video back on to see if you got the correct solutions. Okay, here in the first one, it looks like we can pull out a 9 out of each term, and we can also pull out an x squared. So out comes a 9x squared. Since we factored this 9 out, it's gone entirely. We factored an x squared out of the x to the 4th, so it's an x squared. This one, the 18, we factored out a 9, so now that's a minus 2. And we factored out an x squared. There's one x left there. And then the 27, we factored out a 9, so there's a 3 left there. And the x squared was pulled out entirely. Now this would almost work. We could almost factor this again if that was a minus 3. It would work. But in this form, that's as far as we can go. Number 7, imagine a set of brackets around here. We're going to factor out the x plus 5 term. So that's now out, and the remainders are the x and the plus 3. X plus 3. There's our final answer. Okay, 11 and 13 look to be factored by groups. So if I group off here, I'm going to come down here to write my answer. I can pull out an x squared, leaving x minus 2. And then here I can factor out a plus 5, leaving x minus 2. So my one factor will be that repeated x minus 2, and then I'll have an x squared plus 5. All right, number 13 is a little easier, a little smaller numbers. Block off the first 2 and pull out an x squared, leaving x minus 1. And then we have a plus. We can factor a 2 out of there. 2 times quantity x minus 1. So our one factor will be the x minus 1. And then the leftovers are the x squared and the plus 2. And finally, we have a couple of these. Leading coefficients of 1. So here for the 6, the factors of 6 are 1 and 6, 2 and 3. Then we could reverse that to 3 and 2, and then nothing else is going to work. So what of these numbers would add up to 5? That would add up to 7. Here are the numbers that would add up to 5. So one of the factors is x plus 2. The other is x plus 3. Again, that one's nice. Everything's positive, so everything's positive. All the signs are positive through the whole thing. Here, we've got some negatives. So what are the factors of negative 15? 1 times 15. 2 doesn't work. 3 works, 3 times 5. 4 doesn't work, and then we'd have 5 times 3, the reverse of that. So we want to look across here. Remember, one or the other will be positive or negative. Either the negative is with the 1 or the 15. And if we add those together here, we'd get negative 14. No, this would be positive 14. If I move the negative over here, it would be negative 14. If I put my negative here, I would have negative 3 and 5. That would give me a positive 2. So I want the negative attached to the 5. Negative 5 and 3 add up to negative 2, and then they multiply to negative 15. So there the work is over. My factors are x plus 3 and x minus 5. And since this sign is negative, the bigger of these numbers will get that negative sign to pull the whole thing to the negative side. All right, a few more examples here. This is probably the juiciest one in the lesson. Factoring a trinomial, leading coefficient not 1. So we got 8x squared minus 10x minus 3. The tricky part about this one is there are so many ways we can factor the 8. We could have some 8x times 1x. Or we could have 2x and a 4x. The 3 only factors one way, but it's a big deal. Do we put the 1 here and the 3 here? Or do we reverse that? Put the 3 here and the 1 over... Oops. Grab that 1. And then we'll have a plus and a minus sign there, and we'll have to just FOIL out and see if we can figure out what's going on. Here are all the possibilities that we could guess and check with. Notice down here we have an 8x plus 1, then 8x minus 3, 8x minus 1, 8x minus 3. So all the signs and the numbers are flipping around, and as we FOIL them out, we get different middle terms. And then we will settle on this one, but we'll show you a different way to get there. Instead of doing all that guessing and checking, we can use the ACB method. A times C in this problem, get over there, will be A is 8, C is negative 3, so A times C is negative 24. B is the number in front of X, so our B value is negative 10. We want two numbers that multiply to negative 24 and add up to negative 10. And again, there's a few variations to do this. I would settle on a negative 12 and a positive 2. If I add those numbers, I get negative 10. If I multiply those numbers, I get negative 24. So we're going to bust this term up. We still have the 8x squared, but instead of writing it as negative 10x, we'll write it as negative 12x plus 2x, because that's the same thing as negative 10x if we combined the terms. And then we finish off with the minus 3. Now it's a factor by grouping problem. So if I bracket off the first two terms, I can pull out a 4x, and that'll leave me with a what? 2x minus 3. And then here, this is already 2x minus 3. What can we put out in front here? Just a plus 1 as a placeholder. And then we have our 2x minus 3. So if we combine these, our repeated term will be one of our factors, a 2x minus 3. And then we have a 4x and a plus 1. 4x plus 1. And I would just, I'm always a little cautious. I would double check this. I'm just going to FOIL out my outers and my inners. If I FOIL out the outer terms, I would get a plus 2x. My inner two terms, negative 3 and 4, would be negative 12x. And if I add those together, it does take me to the negative 10. Excellent. Now, difference of two squares. If a and b are real numbers and variables or algebraic expressions, then a squared minus b squared can always be broken down into an a plus b and an a minus b. Notice there's no middle term in there. Since we FOIL this out, here we would have a negative ab, and the inners would be a positive ab, so they're going to cancel. And it says, in words, the difference of two squares of two terms factors as the product of a sum and a difference of those terms. Now, when you see a problem in the wild like this, they're kind of easy to pick out. You're going to have a variable squared at the beginning, or to an even power, and the number at the end will also be a perfect square. Notice there's no middle x term. Over here, there's no middle x term. That's usually the first giveaway that it might be a difference of two squares. So here, I would just set this up with a couple empty sets of parentheses. What's the square root of x squared? It's going to be x and x. What's the square root of 4? It's going to be a 2. One of these terms will be a sum, one will be a difference. X plus 2 times x minus 2. Again, if we do the outers, here the outers are a minus 2x. The inners are a plus 2x. And when we add those up, they cancel out and we have 0 x's in the middle. Okay, now this one, when I look at it, 81 is a perfect square. 49 is also a perfect square. So this is going to work out just nice. What is the square root of 81? Well, it's 9. So our leading terms are 9x and 9x. The square root of 49 is 7. So we're going to have some 7's in there. One will be a plus, one will be a minus. So here our middle terms would be a negative 63x and a positive 63x, and they would cancel out. Example 8. Here it says a repeated factorization. Notice it's not x squared minus 81, it's x to the 4th. So let's set up some parentheses. What do we multiply by itself to get x to the 4th? Well, that's got to be x squared and x squared. What are the square root of 81? 9. 9 times 9 is 81. And I'm going to put the plus first and then the minus. And if you move on to the next problem here, we're not done. This one is left incomplete. The x squared plus 9 cannot be factored any farther, but the x squared minus 9 can. Remember, it's always the difference of squares, never the sum of squares. So the x squared minus 9 is again factorable. The factor of x squared will be x times x, and then 9, the square root of that is 3. One of them is plus, one of them is minus. And I believe this coming up is our last example. Now here, factoring a perfect square trinomial. In the exercises in the homework, the directions will say perfect square trinomial. If that is the case, they've given you a great hint. So here, if we have a polynomial a squared plus 2ab plus b squared, we should be able to break that down into a plus b quantity squared. If we change this minus sign, or change this to a minus sign, our answer is going to be pretty close, but now it's just a minus b quantity squared. Notice we always use the same sign as the middle term. Here is a plus, so that will translate into our binomial. Here it is a minus, that will also wind up in our final answer. And I'll show you how easy these are, especially if you know it's a perfect square trinomial. And here the directions are telling us that it is. This one we could do sort of the old way. We could say, okay, what do you multiply to get x squared? It's got to be x and x. What do you multiply to get 9? It's either 9 times 1 or 3 times 3. And 3 times 3, those 3's would also add up to 6. So you could go after it this way, and you would get an x plus 3 and another x plus 3. And we can be a little more efficient and write that as x plus 3 quantity squared. Now here's the shorter way to do it. If you know in fact that it is a perfect squared trinomial and the directions say that it is, we can just make ourselves a set of parentheses and quantity square it. The square root of this term will just be x. We bring down this sign, positive or negative, and then we square root the 9, 3. And there's a shorter way to do it. And that comes in really handy here, like on letter B. We know it's a perfect square trinomial, so it will be a quantity squared. What's the square root of 25? 5. Square root of x squared? X. Bring down the minus, same sign. The square root of 36 is 6. And here, if you're not sure, we can always check our middle term. You know, if we know this is A and this is B, the middle term is A times B, and then you double it with a 2. Same over here. You got A and B. The middle term will be A times B, and then you multiply that by 2. So let's check our middle term. If I multiply 5x times 6, I get 30x. And then if we times that by 2, we get 60x like we started with. You know, just to check your middle term. If we do it here, 3 times x is 3x, and if we double that, we get 6x, just like it should be. To finish off the video, here are 5 more practice problems, so pause the video, solve the problems, and start it back up, see if you got them right. Okay, let's see what we got here in this first one. Okay, with these big leading terms, this might be a little tricky. I'm just going to recopy it over here, 6x squared minus 17x plus 12. So a times c, 6 times 12 is 72, and our b value is negative 17. So we want two numbers that multiply to 72, add up to negative 17. A little thinking through it will get you a negative 9 and a negative 8. 9 times 8 is 72. The negatives would multiply to a positive. If we add those together, we get negative 17. So I'm going to rewrite that negative 17 in the middle. I still got my 6x squared. At the end, I'll have a plus 12. But in here, I'm going to put a minus 9x and a minus 8x. And then I'll put on there the plus 12. So we haven't really changed the problem. It just looks a little different. Instead of negative 17, we have minus 9 and minus 8. So now it turns into factor by groups. Out of the first group, pull out a 3x, leaving 2x minus 3. Out of the next group, pull out a negative 4, leaving 2x minus 3. And then we put our factors together. One of them will be the 2x minus 3, and then the leftovers, the 3x and the minus 4. Let me just double check those middle, or the middle term. If we multiply the outers, we'd get a minus 8x, and then here a minus 9x. Minus 9 and minus 8 is negative 17. Excellent. All right, number 30. 8x squared plus 33x plus 4. So a times c will be 32, and it's positive. And our b value is 33, and it's also positive. So we want a couple numbers that multiply up to the 32 and add up to 33. Well, that would be 32 times 1. Oop, get out of there. 32 and 1. If I multiply them, I get 32. If I add them, I get 33. Oops. So since this 8 is first, I'm probably going to want to pair it up with the 32x. 8x squared plus 32x. That's supposed to be a 3. And then I have my plus 1x and plus 4. Because 8 and 32 have that common factor, that's why I put the 32 first. So we can factor out an 8x, leaving x plus 4. And then here is the term x plus 4. So we're kind of going to pull out a 1 and put it outside, just as a placeholder. And then we can combine our factors. We got our x plus 4 factor and our 8x plus 1 factor. And there's our answer. All right, now I was a little devious, and I sort of stripped the directions out of here. You know, you're supposed to factor them, but this one actually said factor this perfectly squared trinomial. Now, since I didn't have the directions in there, you might have just done a little ACB method or something, or maybe you thought it through. Okay, 9x squared has to be a 3x and a 3x. There's only one way to factor 1. That has to be 1 and 1. And if I want these to multiply to a positive but add up to a negative, it has to be minus and minus. So if I had left the directions on there, that this was in fact a perfectly squared trinomial, you could have used that little sort of shortcut and said, okay, it's going to be something squared. The square root of this is 3x. That's supposed to be a 3. And then we got a plus 1. Oops, excuse me, that's supposed to be a minus 1 because this sign comes down to our binomial, minus 1. And the last couple ones seem to be the easiest here. Well, I guess these are lower. We should have done these up here. X squared is a perfect square. 144 is a perfect square. Square root of 144 is 12. So to have no middle term, we will have an x plus 12 and an x minus 12. And 42. 64 is a perfect square. 81 is a perfect square. And there is no middle term. So this will also be a sum and a difference. 64 roots to 8. So we'll have an 8x and an 8x. And then 81, if we root that, it'll be 9. One of them is positive, one of them is negative. And there's our last practice problem. I believe for the homework there is a worksheet. If you don't have that, you might be able to look on my teacher webpage on Sapphire. Look in the Chapter 1 folder and look for a P-5 Day 1 worksheet.